All right, let's visit this problem. It says, draw a complete graph. Okay, you have that gives the total revenue of a lemonade stand as a function of X. Revenue is what you bring in, okay? And they gave you the equation. Determine the number of glasses to be sold to produce the maximum revenue. Remember, sometimes when we're making things or selling things, there comes a point where if I don't sell enough, I won't make a profit. If I sell too many, I'm not really making a profit because it's costing me more to keep selling those than I'm getting back. So there comes a maximum time that works best. And a maximum shows up real nicely at the top of your graph. Guys, stay with me. So we want to know what is the maximum daily revenue. That's going to be up here. So we're going to put this into your Y1. So we gave you the equation for your Y1. We gave you this. This had to go into your Y1. So P, we gave you as this. So you had to put this whole thing into your Y1. So Y1 is going to represent revenue. When you get your point in your answer, this is going to be your revenue. X is going to be the number of lemonade glasses that you need to sell. You don't have any other Y here. There's no other Y. So the Y that comes back is your revenue. The X is the number of glasses. So you put it in your graph, and the complete graph means if I multiply this out, X times X squared, isn't that a cubing function? So my cubing function should be more than just a parabola. So I just asked you, where did this graph come from? If you're going to take a look at this, you're going to have to set your mins to negatives, just so that you can see where this is coming from. So I can see where my function is going here. There's my cubic function, up and down. The problem situation is just this piece here. We can never sell negative glasses of lemonade, and hopefully we will never have negative revenue. So revenue is stuff that you get in. So when we take a look at this graph, we find your maximum, and we found your maximum point to be 89 point something or other, comma, 123.345. This is a lemonade stand. So a lemonade stand, would they sell massive amount of lemonade? No. So you can almost kind of guesstimate. I would guess if I'm setting up my window, I would say maximum 100 glasses of lemonade. If they have a really good corner, maximum 100 glasses. If they have a really bad corner, probably 5 or 10 just immediate neighbors, right? This is a lemonade stand. So it's not factory. So you're only looking for just a little bit. And are they going to make massive money at their lemonade stand? I think that's even a pretty good case for a lemonade stand. I mean, yeah.
I would open up a lemonade stand.
Yeah, there you go. Okay, so now, here's your maximum revenue. This was your Y. X the glasses of lemonade, we have to round this because you can't sell a partial glass of lemonade. And the key is when you round this, round down. Oh, this one you have to round up to make sure you make your maximum. Okay, so this one just wasn't rounded because it represents glasses.
Did we round down or did we round up?
What did it come out to be? 89 point what?
I don't know. I'll do it right.
580.
580. Okay, so you need to have sold at least 89 glasses to make that. You didn't sell the 90th one yet, so kind of look at it that way. Okay, you didn't sell. You only sold. How many did you sell right now? If you had a half left, you only still sold 89. So you just have to make sense. Sometimes our rounding rules don't apply. You have to make sense of what it is. So up to now, I can't sell 90. I didn't sell 90. I sold 89. Okay? Questions at all? Good. If you missed that X, it did make it difficult to see what was going on. Now, here's what we worked on yesterday. Cross-sectional is a little bit hard to understand, and really all they're looking at is the front of that trough. Remember I took the sheet of paper and I folded it up? That's all they're looking at, that part and the two sides. as if you made this into like a three-dimensional rectangle. So we said, we worked this out yesterday. We said length times width. Excuse me. Thank you. So we did x times 37. If we're going to pull each little piece in, that's x. We're going to pull in 37 minus x minus x. So minus 2x. And get a max. And again, this says what is my maximum area. This is what goes into y1. Area is x times y. So start this like this. So I got to get an equation in my y1 that says x times y. Since I can't put the y in, I have to have something to get out of the y. In this case, we didn't even bother with it. We just called it x. We didn't call one x and one y. Find your maximum. This represents your area. This represents your x. I think the hardest thing in this was visualizing what they wanted. This took us a little time when we were drawing this out as well, and I have a hard time drawing those things.
I think this was the easiest one on the sheet.
Because we did the drawing. But if we didn't do the drawing, wouldn't it be difficult?
Maybe a little bit. I don't think you need to, like, because technically you don't need to see the drawing.
Well, you need to realize that you're pulling up your side.
It says that.
Yeah, yeah. But that's where you need to get your piece from. Yeah. Okay, and this last one, yes.
Oh, wow.
For number 3, what was the length of the turned up side?
The length of the turned up side was 9 point
Are we
something.
recording right now?
9.25. Yeah.
Wondering.
9.25.
Yes, I think so.
All right, so let's take a look at your last one. Now, a cardboard box is to be constructed with no lid from a 55 by 86 piece of cardboard. And we're going to remove equal squares. A square has 4 equal sides from each corner. And then we're going to fold up the sides. So you're going to cut out, even if you took a piece of paper and you cut out the corners, wouldn't that make it so that you can fold up the sides? Even try those to see how they work. So now, we're removing your side of x. We don't know how much we're going to fold up on the corner, but every corner has an x by x. So technically, your side, your length, you're maximizing your volume. Oh, this is volume this time. Volume is length times width times height. This is going to go into my y1. So now, and what's it going to give me when I graph it if I'm doing a volume? Am I going to get a quadratic? A cubic, an x times an x times an x. So now, my length is 86 minus this x minus this x, so minus 2x. My width is 55 minus x minus x. My height, when I pull up my sides, what is my height? X, right? It's the piece that I pulled up there, x. So I have my 3 pieces, and I plug them into my y1. That's going to give me my volume, and I graph. And again, you're not looking at like a big piece of x, because it can't be much bigger than can't be close to 55. You would never make a box out of this. So
Is the maximum supposed to be max volume, not max area?
yes, max volume. Thank you. Max volume. I'm so used to writing the area. So when you do, yeah, I put my max volume down here. When you do this, like, just kind of makes sense out of this. If I'm cutting corners of a box that has a 55-inch length, I'm not going to cut a lot out of it. Maybe 10, 20 max. I will have no box left if I cut too much out of it. So, kind of figure out where this is going with this. And then, kind of estimate or look at your table. And everybody's comfortable with the table, setting the table set?
You put that whole thing into the calculator, the 86 minus 2.
Yep. This is your length times your width times your height.
Alright.
Because you need it to maximize your volume.
Okay.
Mm-hmm.